Hello everybody, welcome back. Today we're looking at example 3 from 3 decimal tool, applying the sine law. It says a triangle has angles measured 80 degrees and 55 degrees, and the side opposite of angle 80 is 12.0 meters in length. Determine the side length of the side opposite 55 to the nearest tenth, and then determine the length of side AB. Alright, so I'm going to draw this triangle now for you. Here it is. So I just call it ABC. I have angle A, the side opposite, which is lower a, is equal to 12.0, as indicated. Then we have angle 55. 55 and 45 wouldn't matter. Like you could have, the orientation of this angle is fine. It's not going to make a difference. All right, so just be mindful of that. And the side opposite 55 is, we're going to determine the length of that side, so that would be B. We call it lower B. And then we want to know the length of side AB, which would be single side C. Okay. You'll notice I've entered 45 degrees in here. If I know two angles in a triangle, I automatically know the third. So I've added these two up to 135. Took 180, subtracted 135, and I got 45. That's automatic. That's something we knew prior to grade 11. Okay? We learned that, and in the very least in grade 10, if not sooner or prior to that. Okay? So in A, we're going to determine the length of the side opposite 55 degrees. So I write down my formula. Remember, I only ever need two parts of it, okay? So I take that away. And I'm looking for side length, so that's why I picked the side length in the numerator. It's a lot easier to work with. You can do whatever way you want, but like I said, I try to make my life easy. That's why I picked the sine length being in the numerator instead. So then we're going to fill in what we have. All right, so that's step 2. We'll fill in what we know, and we'll go from there. So we know side A is 12. It's 12.0, so we can just put 12 in here. We know the angle is 80 degrees. So we put angle A in as 80 degrees. Side B is what we're looking for. So determine the side opposite 55. We labeled that as B, so we're looking for B. And then we know the angle B is 55 degrees. Okay. All right. Now again, this, right, we can take this away from here and say it's equal to like that. We can interchange those, right? That's okay. That's okay to do that. All right. So I'll do the same thing here. Like we're allowed to interchange, right? Those like that. That's fine. Okay. And sometimes people like to solve for the unknown that they're looking for on the left-hand side. I know that's something a practice I like to do. So the next first thing we do is we got to get rid of the sine 55 on both sides. Right. So multiply both sides by the sine of 55. Right. Okay, and some people put it outside front. Some people put it in the numerator, right? As well, it's all good. It's equivalent. So sine 55 degrees divided by sine 55 degrees is gone. That's why we did it. So let's clean this up. All right. So when we clean this up, the sine 55 are gone. That's why we did it, obviously. So we're just left with B. Oh, just left with B equal to, and you can put that directly in your calculator. All right. Again, you can find them if you want and write them out whatever ways that you're comfortable with. But like I said, it's not necessary. But again, you can do what you need to do. So I'm going to literally plug it in my calculator as I see it right there. Okay. So go to my calculator. I'm going to clear what I already have there, and it's going to be 12 sine 55. So 12 multiplied by the sine of 55. You don't have to put multiply. If you put a 12 up front, it automatically multiplies. Then you're going to divide this whole thing by the sine of 80. All right, sine of 80. Close my bracket, and we hit. Oh, sorry about that. Not 8,000. I apologize. 12 sine 55 divided by the sine of 80. Close my bracket. Hit enter, and I get 9.981. Okay, 9.981. 9.981. Dot. And set to the tenth of a meter, so that's one place after the decimal. So the 8 rounds the 9 up to a 0, which rounds the 9 up to a 10. So it's not just 10, it is still 10, so you got to put 10.0 and put your unit in for your final answer. Okay? So the final answer is the length of side B is 10 10.0 centimeters. Okay? 10.0 centimeters. Next, what we're going to do is we're going to find, determine the length of side AB. So AB is lower C, right? AB, we can also say, or lower C, right? Just be mindful of that, okay? Length from A to B, I like to have one variable, so I call it lower C, all right? So I'll take my formula, look for C, so that's going to be C here over sine C. And then you can pick either one. Like I said, I recommend do the given value, so I'm going to go use A and A here. You could use B and B, lower B and upper B. It doesn't make a difference. It's the same ratio, but I'll use the given values here to make my life easy. Okay? So now we're going to fill in what we know. All right? So side C is what we're looking for. Angle C is it wasn't there. It wasn't given. It's 45 degrees. But remember, we determined that. I always fill in the third angle if I'm given two angles already. And again, we do that by subtracting the two given angles from 180, because three angles in a triangle add up to 180. All right. The A value is 12, and you don't need a decimal zero in your answer. And then the sine of A was 80 degrees. Okay, 80 degrees. Excuse me. So we take our, and we're going to multiply both sides by the sine of 45. Multiply both sides by the sine of 45 degrees. We do it one side, do it the other. And the reason we did that is so the sine of 45 would divide to be 1 and give us just C. All right. And that would leave us with just C equals 12 multiplied by the sine of 45 divided by the sine of 80. All right. So we do that on our calculator. And we get 12 sine 45 sine 80. 12 sine 45 divided by the sine. Make sure you close your bracket here. 80. Make sure your calculator's in degrees, of course. I mentioned that earlier, but double check. And we get 8.616. So we get 8.616. And again, we're going to round that. And that rounds to 8.6 centimeters. Okay. Now, make sure your answers all make sense. Remember, the longest side is opposite to the largest angle. So 12 is the largest side. 55 would have the second largest length, which was 10.0. And 45 would have the smallest side, which is 8.6. So all our answers are reasonable. I always check for that just to make sure. It doesn't hurt to double check to see if all your answers are indeed reasonable. All right. All right. So in example 4, we're solving a problem using the sine law. Toby uses chains attached to hooks on the ceiling and a winch to lift the engines at his father's garage. The chains, the winch, and the ceiling are arranged as shown. Toby solves the triangle using the sine law to determine the angle that each chain makes with the ceiling to the nearest degree. He claims that alpha is 40, theta is 40 and alpha is 54 degrees. Is it correct? Explain why. So what we're going to do is we're going to take this, create a triangle, and see whether or not this is indeed correct. All right. So right away, I look at his claim of 40 and 54. So remember, if this theta was 40 degrees, and you got 2.2 across, and he's saying alpha's 54 degrees across from a smaller side. So right away, the only chance he even has of being correct is they'd have to be on those would have to be interchanged, right? So this would have to be 54 and 40 to even have a chance of being correct, right? So right away I recognize that based on what we know of the side lengths across from angles, that right away, unfortunately, this claim is incorrect. Okay? So what we'll do is I'm going to still calculate that, but that is a statement I can recognize right away. So right away we know it's wrong, right? But I'm going to do the math and show how that works. Okay, so again, we only need two of the ratios. Notice I picked the angle in the numerator for the ratio because we're looking for the angles. We know all three sides lengths already. Okay, so first we'll do is we'll calculate the alpha and just check, right? Okay, so the sine of alpha is what we're looking for. Over the opposite side of alpha, which is 1.9. Again, you don't need the units. You can put the units in when we're done. We know it's going to be degrees anyway, right? As long as these units are all the same, they're all in meters, so we're okay. And then we'll do the given side B. So that would be sine of 86 degrees. 86, and the side opposite of 86 is 2.8 meters. Okay? So that means we got to multiply both sides by 1.9. 1.9. Multiply both sides by 1.9. The 1.9s will divide. I'll give you 1, so this leaves you with sine alpha. Alright, so let's clean this up. So that leaves you with sine alpha equal to. So you can do the inverse sine right away if you're comfortable with your calculator, but if you're still not sure, you want to make double check, just do that now, getting that value. So 1.9 sine 86 divided by 2.8. So I'll do that with the calculator now. So we have 1.9 sine of 86 divided by 2.8. Make sure you close your bracket there before you do that. And enter, and we get 0.6769. So when we did that on our calculator, we got 0.6769 and so on. So now we do the inverse sine. So alpha is equal to inverse sine of that number. And we get alpha equal to, remember you do second function sine, and then you can do second function answer on the calculator we have in class, and that'll automatically bring it to that. Or you could do it manually, inverse sine, and you can put in 0.6769, 1, and just put as many decimal places as you can. Oh, sorry about that. Inverse sine, 0.676918, so on. We enter, we still get 42.6, right? It's a little off, but again, it's still both going to be 42.603. Okay? Okay. So, again, even if he did have them correctly ordered, it's still a bit off for, like it's not quite 40, right? Even though, like I said, I mentioned, he obviously had the angles interchanged, but they were still a little bit off. And to find the third angle is quite easy. We just take 180 and subtract the other angles, right? So to get alpha, or sorry, to get theta, my apologies, theta is going to equal. So to get the theta angle, the third angle, we know two angles, so we just subtract. So we get 180 minus what we just calculated, 42.6, subtract 86. So that would be 128.6. which gives us 51.4 degrees. Okay, obviously, even if they're interchanged, it's still a bit off. Pretty close, but a little bit off. So that's it for this video, for example 4. And the final video, what we'll do is we'll look at example 5 of 3.2. Thanks everybody for watching, and we'll talk again soon.